The first thing that most people are going to do for this question, and they should do it, is put the information that they're told onto the picture. So if they say QR is 20, let's write that. If they say PR is 25, let's write that. And so then just looking at the picture, a lot of people are going to pick choice B because it kind of looks like an isosceles triangle where QP and QR are the same length. And yeah, it does look like that, but they also tell us it's not drawn to scale. So we can't just make that assumption. So this is a very big trap answer. Don't pick this. We've got to do some math here. Sometimes on very, very easy questions near the beginning of the section, the picture will be reliable enough that you can just get to one right answer, but it's very, very rare that we don't need to back up our answer with some work. So that's, know where you are in the test and use your judgment about whether what you're doing is too easy for the difficulty of the question. Instead, what we're going to need to do is some geometry work. So first and foremost, they do give us one more piece of information that we should put on our picture. They tell us that QR is tangent to the circle. What that means is that we're going to form a 90-degree angle between the radius, QP, and that tangent line QR. So that's a thing you need to memorize, that a tangent line to a circle is going to form a 90-degree angle with the radius. Once we do, now we know we have a right triangle, and now we can use Pythagorean theorem to solve for the missing side, which just happens to be the radius, which will be really good to have if we want to find the diameter. But I'm going to show you a little shortcut because a lot of times on the SAT, and especially in the no calculator section, we don't need to go through the motions of Pythagorean theorem. If we see that we have these sides, we want to try to match them up with some kind of very common ratios for right triangles. Maybe you've heard of the Pythagorean triple 3, 4, 5. Basically what that means is lots and lots of triangles follow this proportion because they're easy numbers to work with. We don't have to deal with radicals or anything like that. So the SAT uses this a lot because with the no calculator section, it's a lot easier to just see this proportion and know what the answer is instead of having to do all the motions of Pythagorean theorem. So what we're trying to do is see if it lines up. And the way it lines up is that, like I said, it can be a proportion. So 3, 4, and 5 could be the sides, or so could something like 6, 8, and 10. Notice, just doubling all of the sides. Well, what do we have in this case? We have a 25. That's definitely the hypotenuse. And so that is a jump of times 5. So if we did the same thing to all of numbers, 4 times 5 is 20, so that matches up with side QR, and 3 times 5 would be 15. And so that is the easy way to get the measurement of QP, and since they want the diameter is always double the radius, and so double 15 is 30, and that is the answer. This is a complicated question, but it uses a lot of things that will come up in less complicated questions, like right triangles, 3, 4, 5 right triangles, Pythagorean theorem, tangent lines, and diameter and radius of a circle. Memorize it all.